Hi everyone, this is Miss Zahra, and this is the second part, the second module that's going to be tested in your exam. And this is all about earthquakes, and it's very simple and straightforward. Okay, from this page, they're just going to ask you about the picture, but we don't know which picture. They could ask you to draw a picture or to label this diagram. So let's do both. Okay, if you get a question like this that says, draw waves, draw waves with the characteristics indicated below. Number one, long wavelength. You have to know what is a wavelength and you have to know what is frequency. Wavelength is the distance from crest to a crest. So if I draw my wave over here and I make it long, this is a wavelength that is long. Long wavelength. Anything that has a long wavelength has a low frequency. Frequency means the number of waves. And here you can see there's very few waves. Now, if I want to make a short wavelength with a high frequency, remember I want to keep it the same height because I'm not changing the height, I'm just changing the wavelength. So now I'm going to make many waves and try and keep them, like I said, the same height. I think I made mine a little bit shorter. So do that again. And more of an S shape, okay, not Z shape, an S shape. So now you can see that I have more than the one on top. You can make them even more if you want, okay, as long as you show that one is long and one is short. And remember, the one that is shorter has high frequency, which means high energy. So if I want to increase the energy of my wave, I need to have a lot of waves. So a high frequency with short wavelength. Okay, so this is so important. Okay, so maybe they will ask you, name the parts of the wave and label the waves. So the wave that has an S shape is the trans, with the S, transverse. And just like we see these S's over here, you will see that it also has an S shape. This wave here has a very like a long shape if you look at it. So even though we can see it kind of looks like S, it's a spring. Okay, it's a spring, not an S. And this spring is moving back and forward. So when it's moving up and down, it's going up and down. It's going to make an S shape. When it's going back and forward, it's going to make the long shape. And the long shape's name is longitudinal. Okay, I know it's longitude, but we just say long to remember the long in the word, okay? So longitudinal is our long waves. Transverse with the S wave. Now let's name the parts of the wave. Wave length. I'm looking for a line. Okay. How long is my wave? Is the line going this way? So please look for the arrow. When you see it, we call it wave length. There are two wavelengths shown. Do you see this one over here at the bottom? So there are two wavelengths shown. Then we have amplitude. We all want an A in science. A is our highest score. And that's what amplitude is, the height of the wave. So this one and this one is our amplitude. Amplitude is the height of the wave. Then we have our C shapes, our crest. This is a crest, this is a crest, this is a crest. But why do I not put the word crest over here? Because this is pointing at the line, the line. When you see this line, we are not looking for the word crest, okay? Crest, I just want to know the name of the top of the wave, and it's called crest. There is no line here, okay? There's no line with an arrow. Same thing for trough. Trough, T-U, trough. Okay, look for the T, look for the U. Trough. Crest on the top, trough on the bottom. Wavelength, look for that line. Amplitude, also a line going up and down. But it's the A because we want the A to up in science. Okay, so please memorize the names and the labels and keep practicing them. This is the name of the waves, and then over here, the different parts. Okay, this question will be for 8 marks. Now we're going to talk about the picture on page 97. So this picture, first of all, what is it? This is a recording made from a seismograph. So what made this? The seismograph. And this is the reading that helps me record the earthquake's movement. So during the earthquake, that little pencil was shaking around, and as it shook, it made this recording. The first wave it measured, you will see that it's not as high as the one that comes after, because the first wave it measures is the longitudinal wave. And longitudinal waves move back and forward. They're very quick, but they are not damaging. The transverse wave that goes up and down, it's breaking the ground. It's going up and down. It's breaking it. So it is damaging. So the transverse wave is the damaging wave. From here, what we can tell is maybe they could ask you to circle the area on the picture where the wave is the strongest, which would be over here, right? What else can I tell? Describe it. What do you see? Describe this area. The amplitude, which is the height of the wave, the amplitude is great. If you don't know the word great, you could say high. You could say more. Okay, the amplitude is more. The amplitude is great. The amplitude is high. This tells me the wave is strong. So what's the word for strong wave? Magnitude. Magnitude of the wave here is also, you can use from these words. Great, high. Okay, I'm just going to say great. But you can change it for any of those words. So how can I how can I make the magnitude more, or how can you make it less? By changing the amplitude. If the amplitude is more, the magnitude is more. If the amplitude is less, the magnitude is less. Another thing we're looking for is how close the waves are to each other. If you look over here, you can see that the waves are very close to each other, and that is our frequency. Frequency is how close they are to each other. Okay, so frequency, when they are close, it's high frequency. And high frequency means also high energy. You can also use the word great or more. Like I said, these words, great, more, high, they mean the same thing. You can change them around. Whichever word you remember, you use that to describe. Okay, so here's some examples of questions you may get. The only ones we did not discuss is this question over here and these ones over here. Okay, so the instrument is the seismograph. The Richter scale is a scale that measures magnitude, the strength of the earthquake, using numbers. And the Mercalli scale uses Roman numerals, which are letters like I and V and X. These measure how people felt in the earthquake. So Richter scale measures the magnitude and the energy, and the Mercalli what people felt in the earthquake. And how much does the energy change in the Richter scale? So this is important. From a 6 to a 7 on the Richter scale, it may just be one number, but the amount of energy is 32 times more. So whatever energy the number 6 had, you will multiply that by 32 to tell you how much energy a number 7 has. So between every number on the Richter scale, 32 times more energy is released every time you go up. Okay, here's another way we could ask the question, how do we know when the earthquake is stronger when the lines are closer together? Or higher. You could even have said higher. Which wave is felt first? That would be longitudinal. And if they label the wave and they ask you to name the parts, then you should know that the first is longitudinal and the second one that you get is the transverse. Okay, and what do you think happens to the amplitude as the magnitude increases to become more? As it increases, amplitude also increases. So whatever happens to the magnitude, same thing will happen to the amplitude. And amplitude is greatest at C. Okay, now we're going to look at signs of earthquakes. Again, this is a writing question, and it's about the picture. So you have to understand everything about the picture. You have to know what's happening at number 1, number 2, and number 3, and you have to be able to label the different parts that's going on. Okay, so number 1 over here, the star represents the epicenter. Epicenter is where the earthquake is starting. The break in the earth is called the fault. So the fault is the break in the earth. The first wave, this yellow one, the one that's first, is called longitudinal wave. So our longitudinal wave, the one that's long, is first. After that, the damaging transverse wave comes next. So what happens when we have an earthquake? The first wave, the longitudinal wave, number 1, the longitudinal wave travels quickly, so we feel it first. And the sensors, these things, sensors, they can detect, they can tell, the sensors detect the longitudinal wave. They then send this message. That's what the dotted line is. That message is sent to the alert center. And that center will then send out messages to your devices to tell you about the earthquake when it's coming and its size, so that it can warn people to get out and to be safe.